Hello my dear students, today I am going to explain about a very important short answer question, that is variation of g with height. Okay, let us see whether g value remains same or different at different positions on the surface of the earth and as you are moving away from the surface of the earth. Let us see now. Say this is a planet of mass m and radius capital R. On the surface of the planet, means at a distance r from the center of the planet, let the gravity will be g. Now say you are moving away from the planet by a distance h or by height h, and now you are here or the object is here at a distance r plus h from the center of the planet. Now what is the value of this gravity? At this point we have to see. As we have studied earlier, the value of g is nothing but g m by r square. As g remains constant, universal gravitational constant, m is the mass of the planet remains constant, r is the radius of the planet remains constant, g value at a particular place remains constant. Now let us see what is its value at a height h from the surface of the planet. Say it is gh, which is equal to g, the effective mass of the planet at this point is same as before, that is m by r, means here the distance of the object from the center of the planet is how much? R plus h. So r plus h whole square. That's all. So obviously it is clear that g is changed. As the denominator increased here, g value decreases. It is understood. If h is considerable value, this is our final answer. Means h is half of the radius of the planet, 1/4 of the radius of the planet, or 1/10th of the radius of the planet, or 1/20th of the radius planet. Like this, if it is comparable to the radius of the planet, this is valid. But if h is much less than the value of r, for example, the radius of the planet may be in kilometers, whereas the height is in meters, then this formula is not valid. In that case, we have to find one more formula. That is, if h is much less than r, I am going to compare gh with g as if this is equation number 1, this is equation number 2, I am going to do 2 by 1, which leads to gh by g is equal to gm by r plus h whole square by gm by r square. This gets cancelled and is left with r square by r plus h whole square. To simplify this, I am going to divide both numerator and denominator with r square. That's why it is by r square. This gets cancelled. It's equal to 1 by, this is in brackets and it has whole square by r square. I am going to rewrite this as r plus h by r whole square, which is nothing but 1 by r plus h by r by r get cancelled, and it's nothing but 1 plus h by r whole square. It's like 1 by x square. What is 1 by x square? 1 by x square can be written as x power minus 2. So gh by g is equal to 1 plus h by r whole power minus 2. Now I am going to expand this by using our binomial expansion. In binomial expansion, we know that 1 plus x whole power minus n is equal to 1 minus nx when this x is very small. As here h is very small and r is big value, h by r is very small when compared to this one. So this formula can be applied here. It's like 1 plus x whole power minus n, which is nothing but 1 minus nx, where n is 2 into x is h by r, which leads to gh is equal to g into 1 minus 2h by r. So obviously it is well understood that gh is less than g, means g value decreases as you are moving away from the surface of the planet. That's all. Okay, take my notes, otherwise download the PDF from our app and practice. Okay, see you all with the next lecture.